This is a UTME physics problem, and we have to look for the acceleration of this system given all of this information. To find the acceleration of this system, the first thing we want to do is that we want to break this thing down such that we analyze the motion on this surface and we also analyze this motion as it's going down. First of all, let us note that this string here has a tension in it, and it's the same string that we have here that we have in this place as well. It was just passed over the pulley, which implies that we'll have the same tension in the string. And the acceleration of the system as well, of course, the acceleration of the system, if the system will move, where it's like able to move towards is downward like this. And then from the diagram, we have been given that the acceleration is downward like this. And then the acceleration is not only influenced by this 6 kilogram, it is also influenced by these 3 kilograms as well. What do we do? This top part, let me start with this down part. One thing we should know is that the weight of this object will be acting downward. So let us draw a component. So the weight of the object will be acting downward, and that is the mass times gravitational acceleration, which is 10 meters per second squared in this case. So that implies that we have a weight of 60 newtons acting downward. Now, the next thing is that since there is a string holding this mass in place, the force of tension is a sort of reacting force in a string whenever there is a weight acting on that string. When there's a weight acting on the string, or there's a force acting on the string, especially the one that is fixed or attached to something, the counter action that happens in the string is that there is a tension. And the tension will act in the opposite direction of the applied force. In this case, the applied force is the weight of this object. So we have a tension going upward. Now, this object is accelerating downward, which implies that there is a movement downward. If we come up here, there are two major forces that are governing the whole case here. The first one is the tension that has been generated in the string. In this place, the tension is acting upward for this string. But what happened in this side is that the tension is actually the one responsible for wanting to pull this 3 kg to the right. Therefore, the tension will be acting to the right in this case. But because this surface is a rough surface, that implies that there is a presence of frictional force. If this surface was a smooth surface, we wouldn't have to bother about any other force whatsoever. Not even the weight of this guy has any implication in this motion. If this surface was a smooth surface, the only force would have to consider in the horizontal, if there is no friction here, will be the force of tension. But because this is a rough surface, of course, the direction of motion is going to be to the right. Therefore, direction of friction is going to be to the left. So we have frictional force to the left. Note, frictional force opposes the direction of motion, not necessarily the direction of the applied force. Now that we have been able to get these forces involved, for the horizontal surface, for the surface now, so let me call that the horizontal. What we have there is that tension, which is causing the acceleration, minus ma, so minus frictional force rather, minus frictional force will be equal to ma. Note that anytime we find the net force acting on the system, it will always result in the mass, product of mass times acceleration of the object. So in this place now, the mass we are dealing with, let's call this one m1, and let us call this one m2. So this will be m1a, and this is frictional force in this particular system. Quickly, we can find the normal force acting in this system. Of course, we know that the normal force will be acting upward. So let me call the normal force R. And then we know that the weight of this object is acting downward. That is mg. Like I've said, if not for the frictional force, we wouldn't have needed the weight of this object. So quickly, the vertical component in this particular for the table, so let me just write that this is for the table, this is for the table. Now for the vertical component on this table, what we know is that R minus mg will be equal to 0. And what does that, why is that so? Because there is no movement in the vertical, so the acceleration is 0. Therefore, we are still using our m1g, which implies that R will be equal to m1g. In this case, that would be 3 times 10, which is 30 newtons. Therefore, I can easily get my frictional force, which is the coefficient of friction multiplied by R. Coefficient of friction has been given as 0.5. So 0.5 multiplied by 30, that will be 15 newtons. Getting that and substituting it, that implies that the tension in the string for the table will be represented in this manner. The tension minus 15 equals m1a. m1 is 3. We don't know the acceleration as well. I can call this one, I can say this is equation 1. Equation 1. Now let us go to this other part. For this other part, this one is easy. The acceleration is downward. Normally, if we are going to use the vector method, upward is positive, downward is negative. But I like to always use the direction of motion as the positive direction, such that when I want to equate it to MA, just like I've done here, I would be able to get a perfect result. And I will not have to worry about the sign. I will just use a positive sign. So in this place, we have 60 newtons acting in the direction of motion minus the tension acting against it, which will be equal to the acceleration, the net force, which is mass, which is 6 kilograms times the acceleration, which is acting downward. If I wanted to use the fact that upward is positive, that would be tension minus 60. But as you can see here, the acceleration is downward. I have to consider that as well. So this will be negative 6a and not just 6a. So the implication of this, so this might be confusing. That is why I prefer to use this. But you see that these two are actually the same thing. If you try to maneuver your way around it, take all this one to the right hand side, take this one to the left hand side, and you see that it's the same thing as what is above. Now, I have two equations. I'm going to bring this equation right down here. So this will be 60 minus t equals 6a. Now, what you do here is that you solve this simultaneously and you solve for a and t. We are only asked to find the acceleration of the system, so you don't have to worry about the t. And we can see that we can actually add these two equations up. If we add the two equations, what do we get? We get, adding these two, we have, there's t plus t here plus minus t, that will be 0. And there is negative 15 plus 60, that would be 45. So 45. And if we add this, 3 plus 6, 3 plus 6 is 9a. And that implies that a will be equal to 45 divided by 9. Let me write that properly. 45 divided by 9. And then if you press that on your calculator, you have 45 divided by 9 equals 5 meters per second squared. Now, you can substitute this a into any of these equations to find your tension like that. So if you want to find out your tension, that implies that t minus 15 will be equals 3 times 5. I'm using equation 1 now, and that implies that t will be equals to 3 times 5 is 15 plus 15, which is 30 newtons. And that is how you solve problems like this. If you want to see more videos like this, please subscribe, like, comment, and share. I'll see you in the next one.